Hi everyone, it's Jennifer from Interlochen Public Library, here with my very special guest, Lorelei.
Hi.
Lorelei, can you tell everybody what we're going to do today?
Today we're going to be doing an experiment based on Goldilocks and the Three Bears.
Goldilocks and the Three Bears. Do you remember how that story goes?
So Goldilocks is in the woods and she's walking in the woods and she finds...
Three bears?
No. She finds a cottage. And inside there is 3 bowls of porridge. The largest one for Papa Bear is too hot. The middle one for Mama Bear is too cold. And then the baby one for Baby Bear, the smallest one, it's just right. So she eats all of the Baby Bear's food.
She eats all of the bear's porridge?
Yes.
Did she ask permission?
No.
No. So she just broke into their house and ate their food?
Yes.
Okay. All right. So we're clear. Okay, so does that make sense scientifically that the larger bowl would be too hot, the medium-sized bowl would be too cold, but yet the smallest portion would be just right?
I don't know.
Because really, what is just right, right?
Yeah.
I don't really know. But I think the premise is that the larger would be too hot, medium would be too cold, baby ones would be just right. So, we put hot water in all 3 of these containers 15 minutes ago, and now we're going to take a read to see where we're at. When we first measured it, it was at 175 Fahrenheit, which is under boiling. Lorelei, do you know what the boiling point of water is?
The boiling point of water in Fahrenheit is 212, I think.
212. What is it in Celsius?
100.
100. What's the freezing point?
In Celsius is 0, and then Fahrenheit is 32.
Very nice. All right, let's see what we got here, okay? So we're using candy thermometer. We're at about 125 for Baby Bear. Baby Bear is at 125.
That's a candy thermometer?
It is. Yeah, you can use it for candy.
What
I don't make candy. But this is what it's used for. I'm shaking it. I don't know if that actually does anything, but we'll try. Okay, so Baby Bear was 125.
A Mama Bear is oh, what's going on? It's over Baby Bear now. It's about
It's warmer than Baby Bear.
130, I think? No.
It's creeping up, actually. It's getting there.
Very slowly. Very slowly creeping up there, but it's getting there.
I'd say 130.
130.
Yeah, I'd say 130. It's definitely over
Baby Bears.
Baby Bears.
Which means it isn't too cold.
Shake it. Shake it, shake
It isn't too
shake
cold.
it, shake it.
It's
not.
warmer.
Yeah, it's warmer. Okay. Back down to 100, and let's see what Papa Bear's at.
Papa Bear? Oh, it's going way faster.
It's actually going really fast. It's actually like almost. Yeah, it's going way faster.
It's going really fast.
It's almost up to 150 actually.
It's almost there.
Yeah.
Oh wait, it's still moving. No, it's dead.
It's just under 150. There, you can kind of see that. Okay, so why would more be warmer than less? What do you think?
I think it's because they're in the larger area. There's more molecules. In the larger amount of water, there's more molecules, and then in the smaller amount, there's less
Moving around in there?
moving around. So it takes a shorter amount of time for the molecules to slow down than these fast ones.
Yep. So the more volume you have, the slower rate of cooling. Also, there is surface area to consider. Surface area. Ooh la la. What is that? So as you can see, these 2 jars actually have the same opening length or width, wide mouth. And then this little baby one has a smaller opening. So the larger the surface...
Oh, they do?
They do, yeah. You have to double check?
Yeah.
Okay, make sure I was being honest.
Yeah.
Okay, so the larger the surface, more heat can escape. Smaller the surface,
Let's
So
see.
actually, surface area in this case worked for baby bear's favor and baby bear's favor. But in the story, it says mama bear's too cold. So what are some ideas of why mama's bear would be too cold?
Why would mama's bear be too cold?
Maybe she served herself first.
Maybe she served herself first so
That
that
could be it.
it had more time.
Maybe she was on a diet. We just assumed that mama bears would be a medium-sized serving. Maybe it's not. Maybe she had a super fancy bowl that was really wide and shallow, thus creating
More surface area.
more surface area.
Maybe when she made the porridge, the one serving that she served, so her serving was the amount that she made, so she had to make another serving for baby bear and papa bear.
Oh,
So she had to wait a lot longer because she had to make it.
that's true. Yeah, maybe she made up hers ahead of time. So this year's summer reading is all about imagining your story. So those are some different ways that we can rewrite Goldilocks and the Three Bears. Now we have 3 containers. We're going to do another little experiment with molecules as Lorelai dumps in 1 drop. Go ahead. This is a hot water
In my favorite color.
in blue. Hot. Oh,
Wow.
room temperature, tepid. And then cold, frigid water.
So we put this.
Let's see how.
We boiled this, right? Almost.
No, I just let the faucet run really.
And then we let this sit while this was in the fridge.
We did put this one in the fridge. We didn't have any ice cubes. But can you see how differently? So the hot water
It's spreading.
spreading a lot faster. So
And
the
then-
hot water is dispersing really quickly.
The cold water is pretty slow. Well, actually, yeah, the cold water is pretty slow, and then the room temperature is about in the middle.
Yeah.
From this angle, for us, it looks like this is spread out more, and this is more like tight.
Well, it seems like this one, from our angle, it looks like this one's concentrated more on the bottom.
Yeah, and this one
And
is
this
more
one
like
is
at the
kind of
top.
spreading.
On the top and then like all around. We gotta crouch down for this part.
Yeah. These two
Are faster.
are definitely faster.
First place, second place, last.
And then this one. This one still a lot is on the bottom. So this also explains how molecules work. The faster that they're moving.
It's like if you're biking and you have gears and you go on 7 and you go faster, then when you're on like 1 and you go really slow.
Good analogy. So this little bicycle,
This bicycle
going
is
a lot
going pretty
faster.
fast. This one is medium.
medium.
And
And then
this
now,
Oh wait, no, this one is
the cold one's still struggling. The cold one's still struggling a little.
this one's medium.
Okay.
It's just turning into blue water now.
All right. And this one is pretty. It's pretty much blue. Yeah.
Wait, can I do that? For a
Yeah.
second?
You may. Don't drink it.
Yeah, it's
Okay.
edible.
Well,
Whoa.
thank you
look
for
at
joining us
this.
for today's science experiment. We hope that you can enjoy Goldilocks and the Three Bears. And we have a book recommendation, May I Bring a Friend? It's about permission to bring a friend over instead of just barging in on people's houses. It's a good one.
And don't steal anybody's food.
And don't steal people's food. And then Goldilocks returns. This book is Goldilocks grows up. She feels really bad about what she did, and she goes back, breaks in again, but this time to help fix up the bear's house. This one's by Lisa Campbell Ernst, and this one is by Beatrice Schnick D. Regniers. May I Bring a Friend? Until next time, we hope that everybody is happy, healthy, and reading. Bye!